All right, so there's a lot going on. I want to make sure that everybody understands schedule-wise where things are headed in the coming week and a half. So we've got a in-class lecture we're doing today, and then Wednesday there's a recording for class 22 where we're talking about benefit cost analysis. And it's really important technique for evaluating projects that aren't profitable, for like public sector projects that are done for reasons other than profitability. So please don't miss class 22. I'll post the in-class exercise PDF files on Blackboard, and my recommendation is that as you're watching the video that you pause it and work through the in-class exercises. Don't just copy down the solution of the in-class exercise, which will be included in the video, but try and simulate what you'd actually do in the classroom, which is working through it on your own, kind of thinking through the analysis process. So I think there's a template file that you can use for that lecture, posted on Blackboard already, but the overall point is it's important material that will definitely be on the test, and so I really encourage you not to skip through that one without paying attention. Friday you don't have to pay attention though, because that's October break, so there's no class meeting, no lecture video, it's just a day off. And then a week from today, Monday the 13th, there's another online class recording for class 23. And during class 23, we talk about incremental benefit cost analysis. And we kind of already touched on incremental, that idea on Friday last week. And we're going to talk about a different type of incremental analysis today. But class 23 is another one that's really important, and about half the time there's a question on the final exam related to incremental benefit cost analysis. And so it's important stuff that I'd encourage you to work through the in-class activity and really try and learn that technique. I know that a recorded lecture is not as good as a live lecture, and for me it's probably the social pressure of being in a classroom helps me to focus in a way that I can't manage to do when I'm on my own. And I would imagine other people face the same challenge. And so what you could do is come in here and watch the lecture video sitting in your usual class at the usual time. Just pretend like it's actually happening, but I don't think anybody will actually do that. It's just an idea. So homework 8 is due on Wednesday the 15th. And some of the questions on that assignment are related to today's material, but most of the questions on that assignment are related to things that you're going to learn going through the lecture recording. So while I'm out of town, I will be checking my email. So if you've got questions, you can feel free to send them. I'll do my best to be responsive while I'm away. But then we'll be back in class on Wednesday the 15th. We'll be back in class again. And then Wednesday the 19th of November is when your project's due. All right. So lots of twists and turns, lots of irregularities. Hopefully everybody understands the schedule. Are there any questions about that? All right. I'm excited to talk about incremental rate of return analysis. It is a very valuable technique. Remember, the point of this class is decision making. It is choosing alternatives in a logical, rational way that maximizes economic benefit. And a lot of companies have their own aircraft, especially large companies, where they maybe have multiple locations that they have to move people around, and where executives' time is very valuable, or where it just isn't fair to employees to have them out of town a lot when they could potentially go to a remote location and travel back in the same day. Anybody here ever flown on a private jet before? I've been on it one time. My dad was working for the Kansas City Southern Railroad. Kansas City Southern had a private jet, and we flew it one time from Kansas City down to Texas for a barbecue. It was pretty cool to fly a private jet to a Texas barbecue, but that's been more than 30 years, and I don't think I'll ever get on a private jet again. It's just not looking like I'm going to be that kind of economic player. Marshall doesn't have a jet. Well, actually, no. Marshall does have planes, right? Not a jet, but Marshall's got some planes and I think maybe even a helicopter now, but they don't take civil engineering professors up in those private planes, not Marshall. All right, so let's look at these two different options. The Pilatus PC-12 is a Swiss single-engine turboprop, which you can see has a cost of $2.2 million when new. And what I flew on when I went down to Texas with my dad for a barbecue was a Cessna Citation II, which was a predecessor of the Cessna Citation XL. Nowadays, you can get a Cessna Citation XL. I found a listing online. It was $4 million for the used aircraft. And its operation costs are way higher as well for the jet compared to the turboprop. Turboprops use less fuel. The engines are less complicated. They don't need, well, and there's only one engine instead of two, so that brings the operation costs down as well. And so the ranges are relatively similar, 1,800 miles versus 2,100 miles. The turboprop's slower, and it carries fewer people, but it could be a good alternative if, you know, if you're only going a few hundred miles, then traveling at 333 miles per hour seems like it would probably be good enough. So the question is, how do you know when to go for the jet versus to stick with the plane? How do companies make that decision? And it goes down to the value of the time that's being saved, the distances that they're going to travel, the number of people that they may haul. But there is a technique we can use to compare the difference between the two and decide if that difference is justifiable. And so last time, on Friday, we talked about what is the increment. The increment is the difference between two alternatives. And so if we've got an option A and an option B, remember that we would always sort them in order of cheapest to most expensive. And here option A is on the left because it's the cheaper alternative. And when we compare the two options, we would subtract one option from the other and find out the incremental cost and then the incremental benefits associated with that. And then we would analyze the rate of return of the increment. And so let's actually go over some terminology first and then do an example incremental analysis. The letter I is getting used a lot this semester. And I don't know, for those of you who've been following along in the book, the letter I gets used in different ways for a lot of different variables. And so I thought it would be valuable to just review what we know about the different ways the letter I is used. And so I, capital I, means an interest amount. And so interest is the amount that's paid or earned over time based on the initial amount and interest rate. And so it's a quantity of dollars, whereas the interest rate is expressed as a percentage. So just in general, I with no modifiers on it just means interest rate. Now, I star means rate of return. And we've calculated the internal rate of return before, and that's the rate of return that brings balance or equilibrium between the inflows and the outflows. And internal means that we're assuming reinvestment of the profits back into the project. So I star means the rate of return. Now I prime is the variable that's assigned to external rate of return. And last week we did 3 different practice in-class external rate of return calculations. And I hope that from that you inferred that that's a pretty important technique. The reason why I did it 3 times with you is because it's a little bit tricky. I think it's important to have the practice, but it's just a really valuable technique. So external rate of return is more flexible than internal rate of return because it applies to more situations where you can't necessarily reinvest the profits back into the project. So I prime external rate of return. It's like a weighted average. And one of the components of that weighted average is I sub I, the external reinvestment rate. So when you're calculating the external rate of return, there's some given rate of return that the external profits are put into. That external reinvestment rate, the variable we use for that is I sub I, and then the external rate of return is I prime. Now, finally, delta I star is the rate of return on the increment. So delta means difference between two options, between option A, option B, between the less expensive option and the more expensive option. So if we want to find out what's the rate of return on the difference in cost and the difference in revenue, then that's delta I star. Okay, so these are all terms and definitions and variables that you should know and commit to memory. Any questions about these or the underlying concepts? All right, let's do that example. Let's say that we had two options. We have to do one of them. These are mutually exclusive, so we're not going to do both. We're going to either get option A or option B. And what this is showing is that option B is more expensive than option A, but it also yields a more profit. So which should we do? Should we do option A or option B? Now, you could find out which to do just with present worth analysis. You already know how to do present worth analysis. So incremental rate of return analysis gives you more information because it not only tells you which should be done, but it also tells you what's the rate of return on the additional amount that it costs in order to do the more expensive option. So let's say that our MAR is 10%. That is, maybe we can think of it as how much it cost us to borrow the money. That's oftentimes what sets the MAR as your borrowing cost. And so let me start up Excel and let's do an incremental analysis here comparing these two options. All right. Now, by the way, I didn't show it yet, but here's the decision criteria. And you know, whenever you see this phrase, decision criteria, your ears should start to burn because I love asking people, what's the decision criteria for this analysis or that analysis? It's basically the rules that tell you what to do and why according to that analysis. And so here, the decision criteria for incremental rate of return analysis is find the IRR of the difference, and then if it's greater than or equal to the MAR, then the additional investment is justified. What does that mean, additional investment? The difference it costs. And so let's say that the incremental IRR is above the MAR. Should you get the more expensive option or the cheaper option? The more expensive. So by additional investment, I mean the extra cost for the more expensive alternative. All right, so let's put this together here. There's year, option A, option B, and then I'm going to find out B minus A. And then I'm also going to put in the MAR. So the MAR is 10%, so 0.1. Let me zoom in a bit to make that easier to see. All right, so we've got year 0, 1, 2, 3, and 4. This is a short time horizon here. Option A costs $60,000. Option B costs $73,000. And then the revenue for option A is $22,000 per year. The revenue for option B is $26,225. And then that's the same amount for the remainder of the study period. Luckily for us, both options have the same lifetime here, the same useful life. Okay. So I guess before we do an incremental analysis, we might want to find out if they are suitable options to begin with. Remember that we can use IRR for initial screening. So let's do that. Let's do the initial screening with the IRR equals IRR. Select the values here. And this says 17% for option A, option B 16%, So what's the interpretation of the initial screening? Well, since both of them are greater than the MAR, they're okay. So let me just put a little summary here. Since IRR for each alternative is greater than the MAR, then both options are acceptable. But that doesn't tell us yet which option is best. Okay? So we could do present worth analysis to find out which option is best. And there's a couple ways to do present worth analysis. You know, one is to have amount and then present value of amount and sum up the present value of the amounts using the MAR as the discount rate. Or we could just use the NPV function. So let me do that. It's been a while since we used the NPV function. Anybody remember what's the warning I've given you when you use the NPV function? There is kind of like a be careful of that landmine kind of a warning. Anybody remember what the landmine is when you use the NPV function? Let's just start. Equals NPV. Okay, first thing it wants to know is what interest rate. That's easy enough. We want it to use the MAR as the discount rate. Now, it's asking me to put values in. Do you remember what the warning is for the NPV function?
Don't include the 0.
That's right. Don't put amounts into the NPV function that are already at the present. Otherwise, it throws everything off. So only put in the amounts that are in the future. So the amount that's already at the present needs to be added outside of the NPV function. So if I want to know the present worth of option A, I'm discounting the future revenues and then separately adding in the outflow at the present, which was the purchase price. So that's really important. If you put the whole range of data in there, then it thinks this first value that it sees needs to be discounted by 1 year, and it doesn't. The first value it sees should be the amount that needs to be discounted by a year. So the amount in year 1, not the amount at time 0. Okay, so that's the present worth of option A. I can just pull this sideways and it's going to apply the same function over to option B. So they were both suitable, and this is a further proof that both are suitable. But according to NPV, it also tells us which one is best. So option B is the most profitable alternative, comma, and that's the one that should be selected. All right, good to know. What do these amounts here, what do they mean? We've talked about that before. Last week I gave you, I think on Wednesday, a little concept question where I asked you to write a short answer, like when you find the present worth of an alternative and things are discounted at the MAR, let's say that you borrowed money at the MAR. What does this remaining amount represent?
Is your portion of the profits.
Your portion of the profits. So, you know, it's the present value of your portion of the profits. So like every year when you get this incoming money, if you borrowed the $73,000, some of the incoming money you get to keep, and some of the incoming money has to go back to whoever the lender was to cover their principal and interest. And so this $10,129, that's the present value of your portion of the profits if you borrowed the money. Okay, or if it was your money to begin with, then the way to think about it is you got 10% rate of return and also an extra $10,000 on top of your 10% rate of return. That's what this present worth analysis can tell us. But what present worth analysis doesn't tell us is what is the rate of return on the difference between option A and option B. And so let's just go through the calculation and then I'll explain why that's significant. Yeah.
So the rate of return on the difference, would that be, does that mean like it's telling you, for this particular example, you're paying $13,000
Yep.
more in the beginning. That
Right.
would be your yield on that extra
Uh-huh.
13,000?
Exactly. Yeah, so I'm paying 13,000 extra. So that's option B minus option A. If I pay an extra 13,000, let's say, you know, option A is the cheapest option. It's acceptable. So I'm going to get option A. Well, what if I did an upgrade? So this is like, consider the upgrade. The upgrade's an extra 13,000 one time. And what do you get for that upgrade? You get an extra 4,225 every year for 4 years. So is it worth it? Should you do the upgrade? What if you pay 10% to borrow money? Should you do the upgrade? Is basically, well, are you making more than 10% rate of return on the increment? So let's do that. Let's find the IRR on the increment. Equals IRR, internal rate of return. We just put all of the values into IRR. It's not like NPV. NPV, you can only put in amounts that are in the future. But IRR, you put in everything. So what is the rate of return on the increment? It looks like we're making 11.4%. So let me ask you this. If we could go to Chase Bank here in town and borrow $1 million for 10%, and then we could go to Huntington Bank, deposit that $1 million and make 11.4% rate of return, should we do it? Yeah, if you can borrow money for one rate and earn more, you should try and borrow as much as you possibly can. Keep spending, keep borrowing, as long as your rate of return is greater than the MAR. And so back to the decision criteria here. The decision criteria says if the IRR of the difference is greater than or equal to the MAR, then the additional investment is justified. So in our example, why is it okay to spend an extra $13,000 on the more expensive piece of equipment when, you know, we could have gotten away with buying the cheaper equipment? Why should we spend an extra $13,000? It's because that extra $13,000 yields a rate of return of 11.4%, and we're only paying 10% to borrow that money. So the rule is keep borrowing, keep buying the more expensive thing as long as the additional amount is justified compared to the other alternative. Okay, does everybody understand that? Now, this was just two options. Most of the time in the world, you've got more than two options you're comparing. So what if you've got lots of options? You know, in this illustration, we've got 1, 2, 3, 4, 5 alternatives. And I'm going to walk you through the process of how to know which one to choose. The first thing we should do is screen them using IRR to see if they're suitable. Like, because if one of these options has an IRR less than the MAR, then we should just reject them and not bother to do any kind of incremental comparisons. And so we start off, do the internal rate of return as an initial screen, and both of them pass initial screening. I give you an in-class exercise today, and one of them is not going to pass the initial screening. When that one from today's ICE, when it fails, just you throw it out, and it no longer is part of the analysis anymore. But here we're going to look at all of them. Okay, so the first matchup, we start with the cheapest option, option A. Our first matchup will be option B versus option A. Okay, so we do that. B versus A. You can see that the rate of return on the increment, because it's an extra $12,000 to get B instead of A, and that gives you an extra $3,100 per year. So the rate of return on the increment is 22%. Is 22 bigger than 18? Yes. So we should buy the more expensive alternative. Why wouldn't you? If you can borrow money at 18% and get 22%, borrow the money. Go for it. Okay, so now, after this first matchup, B is our preferred alternative. A was, to begin with, A was best just because it was cheapest and acceptable. But we did this matchup and B came out victorious. So our next comparison, A is dead to us. It's gone. Like B is the current champion. So our next matchup is going to be C versus B. So in the matchup of C versus B, it looks like C is really strong option because the rate of return on the increment is 43%. So now C is our champion, and B, it's gone. We forgot about B. So now we want to do all of the future comparisons against option C. So now let's compare D to C. Okay, in the D to C comparison, the rate of return is 0. So D is not good. The additional $5,000 per year is not justified. So our final matchup is not, well, the final matchup is E versus C. It's not D versus E because we rejected D in this matchup. Once you reject something, you don't do any further comparisons with it. So our last matchup, E versus C, the rate of return is only 14%, so we reject the option E and keep C, so therefore option C is the best. All right, so any questions about that step-by-step process? The overriding principle when you've got multiple alternatives is spend every dollar you can that will bring a greater return than the MAR. All right, so I have a handout for you today. Let me give you these. Okay, so we've got some heavy equipment we are comparing today. You're comparing asphalt compactors. It doesn't really matter what it is. It could be servers, it could be anything. But so how do we order things when we do these comparisons? Cheapest on the left, most expensive on the right. So this is not the order that I've provided the data. So what I want you to do is set this up, first of all, with the IRR analysis. Find out if any of these options should be rejected. And then of the options that remain, do the incremental analysis. And it should look similar to this. It should follow the approach of where you order it from cheapest to most expensive. And then you step by step. You don't know at the outset. By the way, this is really important. Like, you don't know before you start doing the comparisons which matchups are going to be. So you can't say at the beginning, like, B versus A, C versus B, D versus C. Like, the reason why I revealed these one at a time is you only know one matchup at a time what it's going to be. Because depending on the outcome of B versus A, the next one might be C versus A, or it might be B versus C. You don't know until you finish one analysis what the next analysis is going to be. All right, so let me pause. I'm gonna set this one up on Excel, and I'll also be circulating around. If you've got any questions, let me know. let's talk through it here. All right. So the first thing you have to do is order it correctly. I mean, I guess technically you could put it in the original order and try to remember, but it's just so much easier if you sort it from cheapest to most expensive. You're much less likely to make mistakes if you just take a moment up front to sort it cheapest on the left, most expensive on the right. Okay, after sorting, the next thing that we do in this process is the initial screening. And everything except for Komatsu passed the initial screening. And the reason why Komatsu failed is that its IRR was lower than the minimum rate of return. So 12% is our minimum. Komatsu only yields 9. So we reject it, but everything else is acceptable. So that means our first matchup would be the cheapest option versus the next most expensive option. So cat minus deer. And we always need to have it be the more expensive option minus the cheaper option. And the reason why is that we can't calculate a rate of return unless there's an outflow at the present and an inflow in the future. So it's basically you're making some investment at time 0, and that entitles you to a stream of revenue through the future, and we can calculate a rate of return on that. So here, the increment between cat and deer is 11.2% rate of return. If our minimum is 12, 11.2 isn't good enough. So that means we have to reject the more expensive alternative. So in the matchup of caterpillar versus deer, caterpillar loses. So deer remains champion out of the first matchup. The next one would be then deer versus what's the next most expensive one that we haven't rejected yet. So we rejected Komatsu in initial screening. We had rejected cat through the first incremental matchup. So now it's Hitachi versus deer. So more expensive minus the less expensive. So Hitachi versus deer. The rate of return on the increments, 18.6. That's acceptable. So that means we now choose Hitachi. Then we'll do the Volvo versus Hitachi matchup. Negative rate of return. Volvo, not justifiable. So our last one would be Atlas versus Hitachi. Also, that increment is not justifiable because the rate of return, though positive, is still below the minimum of 12. Okay, so we think from this incremental analysis that Hitachi is the best. Let's just confirm that with the NPV. Let's make sure that we don't get a different answer from NPV where we're discounting everything at the MAR, putting only future amounts into the NPV function, and then the stuff that's already at the present, we add external to the NPV function. I meant adding it because the amount at time 0 is already an outflow. It's already negative. What did I do wrong here?
You didn't put the rate in the NPV function.
Thanks. So I thought I did. Let me do that now. Okay.
Yeah, sure.
Yep. So what we should see is the highest net present value should be the same thing that we got for our incremental analysis. Hitachi is best. Hitachi is best. All is right in the world. All right, that's incremental analysis. We're going to carry this through into benefit cost analysis on Monday of next week. Wednesday we'll talk about benefit cost, lecture video of course. So I will see you on Wednesday of next week. And in the meantime, feel free to stop by my office if you've got questions. Send me emails. Have a good day. Yeah.